The first light of dawn broke over the choppy waters of the English Channel, casting a cold, gray hue across the horizon. The air was thick with salt, diesel fumes, and the palpable tension of men who knew the day ahead would be decisive. On the decks of the Higgins boats, the steel-sided amphibious craft that would carry them into history, soldiers of the United States Army and Marines tightened their grips on rifles and fixed bayonets. Each man knew that in just a few minutes, they would be facing the most heavily fortified beaches of Nazi-occupied France. At 5:30, the first wave of Higgins boats pushed off from the landing craft carriers and began the slow crawl toward the beaches of Normandy. The water surged against the flat bottoms of the boats, pitching them with each swell. Soldiers clutched every handhold, knees braced against the metal floor, eyes fixed on the distant shore, barely visible through the morning fog and smoke from naval bombardment. The small, utilitarian vessels were deceptively fragile in appearance, but they had been engineered for one purpose: to deliver men and equipment directly onto hostile beaches, under fire, and keep them alive long enough to establish a foothold. For the soldiers aboard, the Higgins boat was both lifeline and coffin. Its shallow draft allowed it to slide over sandbars that had swallowed older landing craft, but offered almost no protection against the German machine guns and artillery waiting in fortified bunkers. Each boat carried 30 men, a light armored ramp, and sometimes small vehicles or supplies essential for the first hours of the invasion. As they moved forward, the flat bow slowly descended, ready to drop open onto the beach and pour soldiers into the chaos beyond. The sea was alive with other vessels of every size: LSTs, LCIs, destroyers, and support ships. The naval bombardment had begun hours earlier, and already the beaches were outlined by smoke and fire. Yet the German defenses were unbroken, and the soldiers knew that their first steps onto the sand would be met with bullets, shrapnel, and barbed wire. The Higgins boat would be their shield, their conveyance, and in many cases, the first factor in determining who would survive the crossing. Inside the boat, there was a tense silence punctuated by whispered prayers, last-minute words of reassurance, and the clattering of equipment being checked one final time. Private James Miller of the 1st Infantry Division adjusted his helmet and glanced at the officer standing near the ramp. "You ready?" the sergeant asked. Miller nodded, feeling the chill of the morning, the vibrations of the engine beneath his feet, and the enormity of what awaited. Every man on this boat, every soldier in every Higgins boat, carried the same knowledge. Their lives depended not just on their courage, but on the design of this small steel craft and the reliability of the ramp and engine that would deposit them into the maelstrom of combat. The boats surged forward, cutting through the waves in tight formations. Observers in the distance, aboard battleships and cruisers, watched the flotilla advance in precise lines, a testament to American planning and industrial might. Each craft, though small, was a marvel of wartime engineering, simple, robust, and mass-produced to exacting standards. Without the Higgins boats, the invasion plan, Overlord, would have been almost impossible. Larger, deeper draft landing craft risked grounding on hidden sandbars, while smaller, improvised boats could not carry enough men or equipment to establish the vital beachhead. As the first gray outlines of the beach emerged, the soldiers could make out the obstacles that awaited them: wooden stakes, mines, tangled barbed wire, and the eerie shapes of pillboxes dotting the cliffs above. Mortar fire from the defenders exploded nearby, sending sprays of water and sand over the steel decks. The Higgins boats pitched and rolled, but the men held their positions. Every second brought them closer to the sand that would either claim their lives or become the site of the turning point of World War II. The ramp mechanisms, designed by Andrew Higgins and his engineers in New Orleans, would soon prove their worth. Within moments, the steel bow would drop, creating a bridge from the boat to the sand, allowing men to charge forward even as bullets raked the deck. Unlike other landing craft, the Higgins boat was low, fast, and able to land on beaches with as little as 2 feet of water at high tide. Its flat bottom allowed vehicles and artillery pieces to be pushed directly onto the shore. Every detail, the hull, the ramp, the engine placement, the shallow draft, had been designed for one purpose: survival, speed, and the effective delivery of combat power on fortified beaches. As the dawn deepened, the soldiers in the first wave prepared themselves. The approaching shore was now visible in stark relief through the morning mist. The first shots rang out, the water erupted around the boats, and the Higgins boats carried their human cargo into history. The simple, elegant design of these craft, a design forged in the swamps and rivers of Louisiana, would be credited with saving thousands of lives and making the success of D-Day possible. Without them, the beaches of Normandy could have been a slaughterhouse. With them, they became the beginning of liberation. Long before the beaches of Normandy echoed with gunfire, before steel ramps slammed into wet sand under machine gun bursts, the story of the Higgins boat began far from Europe, in the swamps and bayous of Louisiana. Andrew Jackson Higgins was not a naval admiral, nor a graduate of a prestigious military academy. He was a businessman, a problem solver, and above all, a stubborn designer who believed boats should go where other boats could not. Born in 1886 in Columbus, Nebraska, Higgins did not grow up near oceans or great shipyards. His early life was shaped by railroads, lumber, and trade. It was only later, in New Orleans, that he would find his calling. There, surrounded by shallow rivers, shifting sandbars, marshlands, and unpredictable tides, Higgins began designing small workboats for oil companies and loggers, vessels that could operate in places where traditional deep-draft boats would run aground. He learned something critical in those swamps. A boat that cannot reach the shore is useless. In the 1930s, Higgins developed what he called the Eureka boat, a shallow-draft craft with a spoon-shaped bow and a powerful engine, capable of pushing through mud, reeds, and debris. Oil workers loved it. Loggers relied on it. It could skim over obstacles that stopped conventional hull designs cold. The U.S. Marine Corps took notice. At the time, American military planners were studying the possibility of amphibious warfare in the Pacific. The problem was not courage. The problem was delivery. How do you move men from ship to hostile shore without forcing them to climb over the sides of boats under enemy fire? How do you land on reefs, coral, and sandbars without getting stuck? The Marines had experimented with various landing craft. Most required soldiers to climb over the side once they hit the beach. In training exercises, this proved slow and dangerous. In combat, it would be catastrophic. Higgins believed he already had the answer. When the Navy tested his Eureka boat, it performed better than expected in rough coastal conditions. It could approach shallow beaches without grounding. It was maneuverable, tough, and simple to repair. But there was still a flaw. Men still had to climb out over the sides. According to historical accounts, Higgins observed Japanese landing operations in China, where boats used bow ramps to disembark troops quickly. He immediately recognized the advantage. A front-loading design would allow soldiers to exit directly onto the beach in seconds rather than scrambling over gunnels. He redesigned the hull. The spoon bow was replaced with a squared-off front section and a metal ramp that could be lowered mechanically. Reinforced sides offered some protection. The engine placement was adjusted to balance weight. The flat bottom remained, crucial for beach landings in shallow water. The result was the landing craft, vehicle, personnel, the LCVP. It was not elegant. It was not glamorous. It was a box of wood, steel, and practicality. But it worked. Higgins himself was known for his temper, his blunt speech, and his relentless demands for efficiency. He pushed his workers hard. He argued with Navy officials. He challenged bureaucrats. But he delivered results. By 1941, as the United States edged closer to full involvement in World War II, Higgins Industries in New Orleans was scaling production at a pace few thought possible. What began as a regional boat company was transforming into a wartime industrial powerhouse. President Dwight D. Eisenhower would later reportedly say that Andrew Higgins was the man who won the war for us. It was not hyperbole, because wars are not won only by generals and divisions. They are won by systems, by logistics, by transport, by the ability to move men and machines precisely where they are needed. Higgins understood that amphibious warfare was not about a single dramatic landing. It It was about repetition, reliability, and speed. If you could land 30 men safely once, you could land thousands. If you could land thousands, you could build an army on a hostile shore. The Higgins boat was not born in a grand naval laboratory. It was born in muddy riverbanks, shaped by civilian industry, and refined through stubborn persistence. And by 1944, the design that began in Louisiana would carry Allied soldiers not just on the beaches, but into history. At first glance, the Higgins boat did not look like a revolutionary machine. It was boxy, low in the water, built from plywood and steel rather than heavy armor. It lacked the imposing silhouette of a battleship or the sleek profile of a fighter aircraft. And yet, inside its simple lines was one of the most important engineering solutions of the Second World War. The official designation was Landing Craft, Vehicle, Personnel, LCVP. But what made it revolutionary was not its name. It was how every single feature was engineered around one brutal reality. Men would be stepping into gunfire. The hull measured approximately 36 feet in length and just over 10 feet in width. This compact size allowed the craft to be transported aboard larger ships and deployed in large numbers. But the key innovation was the shallow draft, just around 2 to 3 feet when loaded. That meant the LCVP could approach beaches that would stop deeper vessels cold. Previous landing craft often grounded too far from shore, forcing soldiers to wade through chest-deep water while carrying heavy packs and weapons. Many drowned before reaching land. Higgins eliminated that fatal gap. The flat-bottomed hull was critical. Unlike traditional V-shaped hulls designed for open ocean efficiency, the flat design distributed weight evenly and allowed the craft to slide directly onto sandbars and beaches. It sacrificed some comfort in rough seas. Soldiers often endured violent pitching, but it ensured proximity to the objective. Then there was the ramp. The bow ramp was a mechanical solution to a tactical nightmare. Instead of climbing over the sides, exposed and disorganized, soldiers could charge forward in a tight formation. The ramp was reinforced with steel plating, hinged at the base, and operated by a simple but reliable pulley and winch system. When lowered, it created an instant bridge between sea and land. Speed mattered. Powered typically by a gray marine diesel engine producing around 225 horsepower, the LCVP could reach speeds of roughly 12 knots in calm water. That was not fast by naval standards, but in an amphibious assault, speed reduced exposure time. Every second shaved off the approach reduced casualties. The internal layout was brutally efficient. The cockpit was positioned at the rear starboard side, slightly elevated for visibility. The coxswain, often just a young enlisted sailor, was responsible for navigating through obstacles, incoming fire, and chaotic surf conditions. Behind him sat the engine compartment. The remaining space was dedicated entirely to cargo, up to 36 fully equipped troops, or a jeep, or roughly 8,000 pounds of supplies. Armor was minimal. The sides were built primarily from marine-grade plywood over a wooden frame, reinforced with steel plating in critical areas. The design philosophy was clear: protection through speed and numbers, not heavy armor. If one craft was lost, dozens more would follow. This was industrial pragmatism at its finest. The LCVP was also easy to repair. Damaged panels could be replaced quickly. Engines were standardized. Parts were interchangeable. In the chaos of global war, maintainability became as important as firepower. Perhaps most importantly, the design allowed versatility. The same boat could land infantry in Normandy, Marines on Pacific atolls, or supplies in North Africa. It could operate from large transport ships or smaller carriers. It functioned in calm, tropical lagoons and cold, rough Atlantic waters. It was not a specialized machine. It was a system component, a repeatable tool in a vast logistical network. In engineering terms, the Higgins boat was not about innovation for its own sake. It was about applied simplicity. Every curve, every joint, every bolt served a purpose. It was designed to be mass-produced, loaded quickly, deployed rapidly, and sacrificed if necessary. And that is what made it powerful. Because modern war was no longer about singular heroic charges. It was about throughput, about how many men you could move per hour, how much equipment you could land before the enemy reorganized. The LCVP turned beaches into doorways. It converted coastline into infrastructure. And in doing so, it changed the mathematics of amphibious warfare forever. A design on paper means nothing until it meets water. By the late 1930s, the United States Marine Corps understood that any future war in the Pacific would require amphibious assaults against fortified islands. But theory and reality are rarely the same. Landing craft that looked promising during demonstrations often failed under real surf conditions. When the early Higgins prototypes were tested, they were not evaluated in calm harbors. They were driven into rough coastal waters, into mud flats, across reefs, and onto unpredictable shorelines. Military observers watched closely, clipboards in hand, as boats grounded, engines stalled, and crews improvised solutions. The initial Eureka boat performed impressively in shallow approaches. But exercises quickly revealed a critical problem. Troops exiting over the sides became disorganized and vulnerable. In simulated combat landings, even a few seconds of delay multiplied into chaos. Men stumbled. Equipment snagged. Formation collapsed. The Marines reported bluntly, "This would not work on a live fire." Andrew Higgins did not argue the data. He redesigned. The addition of the bow ramp transformed the landing process, but it introduced new engineering challenges. The front section of the hull had to be reinforced to withstand repeated impact with sand and obstacles. The hinge mechanism had to survive saltwater corrosion and constant mechanical stress. The ramp had to lower quickly and, just as importantly, raise again if the craft needed to withdraw. Field trials were relentless. Boats were deliberately driven onto rocky shores to test hull integrity. Ramp mechanisms were cycled repeatedly to identify weak points. Engines were run at sustained high RPM to expose overheating issues. Military testers evaluated how quickly a full load of infantry could disembark. Seconds were measured and compared. One lesson became immediately clear. Surf was the true enemy. In heavy waves, flat-bottomed craft could slam hard against the water surface. Too light, and the boat would lose stability. Too heavy, and it would sacrifice shallow water advantage. Engineers adjusted internal framing, redistributed weight, and reinforced the keel. Then came obstacle simulations. The Navy and Marine Corps began constructing beach defenses during training exercises, wooden stakes, mock mines, wire entanglements, to replicate what troops might encounter in Europe or the Pacific. Higgins boats were forced to navigate these hazards under time pressure. Some craft were damaged. That was the point. Better to break prototypes in training than lose men in combat. By 1941 and 1942, as the United States formally entered World War II, the Higgins design had evolved from civilian adaptation into a standardized military platform. Each round of testing tightened tolerances, strengthened joints, simplified controls, and eliminated unnecessary complexity. Another key refinement involved coordination. Landing craft did not operate alone. They moved in waves, in formation, often under cover of naval artillery. Timing was everything. Tests focused on launch procedures from larger transport ships, how quickly boats could be lowered, loaded, organized, and dispatched. Efficiency improved dramatically. Crews practiced synchronized landings. Coxswains learned to read surf patterns and compensate for cross-currents. Communication protocols were refined. What began as an experimental craft was becoming part of a much larger operational system. The Pacific Theater provided early combat validation. During amphibious assaults in places like Guadalcanal and North Africa, Higgins boats faced real enemy fire for the first time. Reports flowed back to engineers. Some crews requested additional shielding near the cockpit. Others recommended minor structural adjustments. Higgins Industries responded rapidly. Production lines incorporated improvements almost immediately. The beauty of the LCVP design lay not just in its simplicity, but in its adaptability. By the time preparations for Operation Overlord intensified in 1943, the Higgins boat was no longer a prototype or experimental platform. It was battle-tested, refined through surf, sand, coral reefs, and live ammunition. It had been broken, adjusted, strengthened, and proven. And when thousands of them assembled in British ports before D-Day, they represented more than boats. They represented years of iteration, a quiet engineering evolution that would determine whether soldiers could reach shore in seconds instead of minutes. In amphibious warfare, minutes cost lives. The Higgins boat had been shaped by that truth. Design wins battles. Industry wins wars. By 1942, the Higgins boat was no longer an experiment. It was a necessity. Amphibious operations were expanding across the Pacific. Planning for a return to Europe had begun. Military planners did the math, and the numbers were staggering. Thousands of landing craft would be required. Not dozens, not hundreds, thousands. Andrew Higgins' shipyard in New Orleans transformed almost overnight from a regional manufacturer into one of the most important wartime industrial centers in the United States. What had once been a company building workboats for oil fields became a round-the-clock production engine feeding a global conflict. Higgins Industries expanded rapidly. New facilities were constructed along the Mississippi River. Assembly lines were reorganized for speed. Processes were standardized. The LCVP was engineered not only for performance, but for manufacturability. This was critical. The craft's hull relied heavily on marine-grade plywood over a wooden framework, reinforced with steel in key stress areas. Wood was faster to shape, required fewer strategic materials than all-steel hulls, and could be worked by semi-skilled labor after brief training. In wartime America, speed of output mattered more than perfection of finish. Sections were prefabricated. Hull panels were cut and assembled in modular fashion. Engines arrived from suppliers ready for installation. Ramps were built in batches and fitted into reinforced bows. Each step was optimized, each delay analyzed. Production accelerated. At peak output, Higgins Industries was producing dozens of landing craft per day. Workers operated in shifts that ran through the night. The rhythm of hammering, welding, riveting, and engine testing echoed continuously across the shipyards. And the workforce itself reflected the transformation of American society during wartime. Women entered the shipyards in large numbers, filling roles once reserved for men who were now overseas. African American workers, previously excluded from many industrial jobs, became part of the integrated production force at Higgins Industries, one of the first large-scale industrial employers in the South to promote a more inclusive workforce under wartime pressure. The factory floor became a battlefield of its own, not against bullets, but against time. Every boat completed meant another platoon that could land under fire. Every delay meant risk. Quality control remained strict despite the pace. Hull seams were inspected. Engines were tested before shipment. Ramp mechanisms were cycled repeatedly. The LCVP had a function on the first try. There would be no second chance under machine gun fire. By 1944, more than 20,000 landing craft of various types had been produced by Higgins Industries alone. The LCVP became the backbone of Allied amphibious operations. They filled British ports ahead of Operation Overlord. They gathered in Pacific staging areas for island assaults, from Louisiana swamps to European beaches. The sheer scale was unprecedented. Each boat was relatively small, individually unremarkable, but collectively they represented something new in modern warfare: industrialized mobility. The ability to move entire divisions across water and deposit them directly onto contested shores. Mass production turned the Higgins boat from a clever engineering solution into a strategic weapon. It allowed planners to think bigger, to schedule synchronized landings across multiple beaches, to replace losses quickly, to treat amphibious assault not as a desperate gamble, but as a repeatable operation. By the time the Allied invasion fleet assembled in southern England in the spring of 1944, rows upon rows of Higgins boats floated beside transport ships. Identical, functional, ready. each one built by workers who had never seen Normandy, but whose craftsmanship would determine what happened there. The Higgins boat was no longer just a design. It was an industrial phenomenon. And without that industrial surge, there would have been no armada large enough to attempt the liberation of Europe. Before the gray waters of the English Channel carried Higgins boats toward Normandy, they had already faced war. Combat is the final test of any machine. Blueprints do not matter under live ammunition. Production numbers mean nothing if the design fails under pressure. The Higgins boat would have to prove itself, not in theory, but under fire. Its first large-scale combat use came in November 1942 during Operation Torch, the Allied invasion of North Africa. American forces, many inexperienced in amphibious warfare, approached hostile shores along the coast of Morocco and Algeria. The landings were complex. Coordination was imperfect. Sea conditions were unpredictable. But the Higgins boats performed. They moved infantry units from transports to beaches that lacked proper harbors. They grounded in shallow water as designed. Ramps dropped. Soldiers disembarked quickly. There were delays, confusion, scattered resistance, but the boats delivered men to land. For the first time, the LCVP proved that large-scale amphibious assault was feasible. The lessons learned in North Africa were immediate. Some crews reported difficulty navigating surf in unfamiliar coastal patterns. Minor modifications were introduced. Procedures were refined. Training intensified. Then came the Pacific. If North Africa was a test, the Pacific was a crucible. In August 1942, during the landings at Guadalcanal, Higgins boats carried U.S. Marines toward heavily contested beaches surrounded by jungle and coral reefs. Conditions were harsher than many planners had anticipated. Coral formations threatened hulls. Shallow lagoons challenged navigation. Heat strained engines and crews alike. The flat-bottom design showed its strength. Unlike deeper draft vessels, the LCVP could approach reefs more closely. When they grounded on coral, they were often close enough for Marines to reach shore quickly. The bow ramp allowed organized movement under chaotic conditions, but the Pacific exposed vulnerabilities as well. Japanese defensive fire was intense. Machine guns raked beaches. Mortars targeted landing zones. The minimal armor of the Higgins boat meant that once enemy fire found range, casualties could mount quickly. Yet the solution was not heavier armor. It was speed, numbers, repetition. Wave after wave of Higgins boats moved toward contested shores. If one was disabled, others followed. The craft became part of rhythm. Approach, drop ramp, unload, withdraw, return. At Tarawa in 1943, one of the most brutal amphibious battles of the war, the importance of shallow draft became tragically clear. Some larger landing craft were stranded on reefs hundreds of yards offshore. Soldiers were forced to wade through chest-deep water under heavy fire. Higgins boats, though not immune to grounding, were often able to get closer. Every yard mattered. Every second saved meant fewer lives lost in open water. Reports from Pacific commanders emphasized adaptability. LCVPs were used not only for infantry landings but for delivering supplies, evacuating wounded, and repositioning units between islands. Their reliability made them indispensable. By 1943, amphibious doctrine had matured. Landing craft were no longer experimental additions to naval operations. They were central components. Timing between naval bombardment and troop landing became more precise. Air support was coordinated. Engineers began clearing beach obstacles faster. And through it all, the Higgins boat remained the constant. It was present at Sicily, at Salerno, in the Gilbert and Marshall Islands, in New Guinea, in dozens of landings that rarely made headlines but collectively built Allied momentum across two oceans. Each operation refined technique. Each beach revealed new adjustments. By the time preparations began for the invasion of Western Europe, the Higgins boat was no longer an unproven innovation. It was combat-hardened, its strengths understood, its weaknesses accounted for. Most importantly, commanders trusted it. That trust would be critical, because Normandy would require something unprecedented: Thousands of landing craft operating simultaneously under coordinated naval and aerial fire against one of the most fortified coastlines in the world. The Higgins boat had survived North Africa. It had endured the Pacific. Now it would face its greatest test. By the spring of 1944, the Higgins boat was no longer an experiment, no longer a regional innovation from Louisiana. It had become the backbone of the largest amphibious invasion ever attempted. Operation Overlord required scale beyond anything previously seen in warfare. Nearly 160,000 Allied troops would cross the English Channel in a single day. Thousands of ships would support them. Air cover would blanket the skies. Naval artillery would pound the coast. And at the center of this immense logistical machine were the landing craft, especially the LCVP. More than 4,000 landing craft of various types participated in the Normandy invasion. A significant portion were Higgins boats. They were the final link in the chain. Battleships could shell bunkers. Bombers could strike inland targets. But only the Higgins boat could carry a platoon from transport ship to stand under fire. In the early hours of June 6, 1944, staging areas along the southern coast of England were alive with motion. Higgins boats were lowered from transports into dark, cold waters. Engines coughed to life. Coxswains checked bearings. Soldiers climbed down cargo nets. Packs heavy, weapons secured. Each boat carried around 30 to 36 men. Multiply that by thousands. As the first waves formed into lines across the channel, the operation became a synchronized movement of wood, steel, and human resolve. Naval bombardment began before dawn. The horizon flashed with artillery fire. Smoke drifted over the coastline of France. Then the Higgins boats advanced. At Omaha Beach, conditions were especially brutal. German defenses were intact. Machine guns covered open sand. Artillery had pre-registered firing zones. Beach obstacles, steel hedgehogs, mine stakes, and barricades awaited the incoming craft. The LCVPs moved forward through heavy surf. Some struck underwater obstacles. Others took direct hits. But the design allowed them to push close enough to shore to deploy troops rapidly. Ramps dropped. Men surged forward. Seconds later, the boats reversed engines and pulled away to retrieve more soldiers. Speed was survival. At Utah Beach, currents carried some landing waves off target. Yet the shallow draft of the Higgins boats allowed rapid adjustment and landing on alternative sections of coastline. Troops reorganized quickly and pressed inland. On Gold, Juno, and Sword beaches, British and Canadian forces relied on similar landing craft to deliver infantry and light vehicles. Across 5 assault beaches, the Higgins boat and its counterparts operated continuously, wave after wave. Some were destroyed, but many returned, and returned again. The true power of the Higgins boat on D-Day was not armor or firepower. It was throughput. It enabled constant reinforcement. Even when initial waves suffered heavy casualties, follow-up waves continued landing. Engineers disembarked with explosives to clear obstacles. Medics evacuated wounded back onto returning craft. Supplies flowed in. By midday, despite chaos and losses, the beaches were no longer isolated kill zones. They were becoming footholds. The mathematics of invasion had shifted. Without the ability to land thousands of men in hours, not days, that the German defenders might have contained the assault. Instead, the sheer volume of troops delivered by landing craft overwhelmed localized resistance. The Higgins boat turned coastline into access. It transformed a fortified beach into a logistical gateway. By nightfall on June 6th, Allied forces had established a precarious but undeniable presence in Normandy. It was not secure. It was not tidy, but it was real. And behind nearly every soldier who stepped on a French sand that morning stood a small landing craft with a flat bottom and a steel ramp. The Higgins boat did not win the battle alone, but without it, the battle could not have been fought at that scale. D-Day was not just a test of courage. It was a test of engineering. The beaches of Normandy were not ideal landing zones. They were carefully selected killing grounds. German planners had studied tidal charts, mapped sandbars, installed obstacles at calculated depths, and zeroed artillery on approach lanes. Any weakness in landing craft design would be exposed within seconds. The Higgins boat survived that test for several reasons. First, shallow draft. At high tide, underwater obstacles were partially concealed. At low tide, sandbars stretched far from shore. Larger landing ships risked grounding too early, forcing troops to disembark into deep water. The LCVP's draft of roughly 2 to 3 feet allowed it to push closer than most alternatives. That final 30 to 50 yards made the difference between organized deployment and chaotic waiting under fire. Second, the flat bottom. Traditional V-shaped hulls are efficient in open ocean, but struggle when beaching. The flat bottom hull of the LCVP distributed impact force when striking sand. Instead of digging in sharply, it slid forward. That allowed coxswains to maintain forward momentum even in rough surf. Momentum meant control. Control meant precision. Third, the bow ramp. In earlier amphibious designs, troops had to climb over the sides. Under machine gun fire, this cost time and cohesion. The ramp transformed disembarkation into forward movement. Soldiers exited in formation, rifles already pointed inland. The ramp dropped in seconds. Seconds were everything. Fourth, weight balance and engine placement. The engine sat toward the rear, keeping the bow lighter during approach. This prevented premature nose-diving into sand and allowed smoother contact with the beach. Once grounded, the rear-weighted design made it easier to reverse off the sand after unloading. Retreat capability was critical. Landing craft were not disposable in theory. They were part of cycle. Land, unload, withdraw, reload. The faster that cycle operated, the faster reinforcements arrived. Fifth, simplicity. The LCVP was not mechanically complex. Controls were straightforward. Repairs were manageable. If a ramp jammed, it could often be forced open. If a hull panel was punctured, field repairs were possible. Complex machines fail catastrophically. Simple machines fail gradually. In Normandy's chaos, gradual failure meant survival. Sixth, scalability. Because thousands were built, commanders could plan operations assuming losses. This changed operational psychology. The invasion plan did not rely on a handful of specialized vessels. It relied on repetition. If one Higgins boat was destroyed, another followed minutes later. Engineering created redundancy. Redundancy created resilience. But the design was not invulnerable. The LCVP offered minimal armor. Heavy machine gun fire could penetrate its sides. Artillery could destroy it outright. Many boats were lost on D-Day. Yet the alternative, heavier armor, would have increased draft, reduced speed, and limited production scale. Higgins had chosen correctly. The boat was designed not to win firefights. It was designed to deliver men to them. And in that role, it performed exactly as intended. As the tide shifted and more waves reached shore, the beaches transformed. Engineers cleared obstacles. Tanks rolled off larger landing ships. Supply crates piled up. Communication lines formed. The Higgins boat's contribution was not glamorous. It was foundational. It created the initial transfer of force, the moment when water ended and land began. In military terms, it converted a contested shoreline into a viable supply point. In human terms, it gave soldiers a fighting chance. The genius of the Higgins boat was not that it was indestructible. It was that it was sufficient. Sufficiently shallow. Sufficiently fast. Sufficiently simple. Sufficiently numerous. In an industrial war, sufficiency at scale wins battles. The Higgins boat was never meant to fight. It carried no heavy guns. It offered minimal armor. It could not bombard fortifications or dominate open water. And yet, strategically, it became one of the most consequential weapons of the Second World War. Because modern war is not only about firepower, it is about mobility. Before the widespread use of standardized landing craft, amphibious assaults were rare, risky, and often improvised. Armies relied on capturing ports. Naval invasions required intact harbors. If a defended coastline lacked a usable port, large-scale landings were nearly impossible. The Higgins boat changed that equation. It turned open coastline into a viable entry point. This had enormous strategic consequences. In North Africa, it allowed Allied forces to establish footholds without relying on major port cities. In Sicily and Italy, it supported landings that forced Axis forces into defensive withdrawals. In the Pacific, it made island hopping possible, bypassing heavily fortified strongholds and striking weaker points instead. The boat enabled flexibility. Flexibility created unpredictability. Unpredictability forced the enemy to defend everywhere. Germany's Atlantic Wall stretched across thousands of miles. Hitler and his commanders could not know exactly where the invasion would come. The existence of thousands of landing craft meant that the Allies had options. They could plan multiple landing scenarios simultaneously. The Higgins boat was a multiplier. It multiplied landing points. It multiplied operational tempo. It multiplied the speed at which forces could be deployed. And because it was mass-produced, it allowed planners to think in waves, not singular assaults. On D-Day alone, more than 150,000 Allied troops were landed in Normandy within 24 hours. That level of throughput would have been impossible without standardized, repeatable landing craft. But the impact extended beyond a single day. Once the Normandy beachhead was secured, landing craft continued ferrying reinforcements, vehicles, artillery, fuel, and ammunition. They operated as floating arteries, sustaining the expansion of the front. The Higgins boat helped transform amphibious assault from a desperate gamble into a repeatable operational tool. In the Pacific, this shift was even more pronounced. Island after island fell not because the Allies destroyed every defensive position from sea, but because they could land forces wherever terrain allowed. Even heavily fortified islands could be isolated and bypassed. The Japanese military was forced into a defensive posture across vast ocean distances. Mobility reshaped strategy, and mobility required delivery systems. The Higgins boat also influenced post-war military doctrine. The success of large-scale amphibious operations reinforced the importance of rapid deployment capabilities. Future conflicts would build upon this model, refining landing craft into armored amphibious vehicles and hovercraft. But the conceptual breakthrough had already occurred. You did not need a port. You needed landing craft. It is often said that President Dwight D. Eisenhower later credited Andrew Higgins as one of the individuals who made Allied victory possible. Whether apocryphal or not, the sentiment reflects a larger truth. The outcome of global war can hinge on logistical innovation. The Higgins boat did not capture cities. It did not fire salvos. It did not appear in triumphant victory parades, but it allowed armies to arrive. And in war, arrival is everything. Without the ability to place combat power precisely where it is needed, strategy collapses into theory. The Higgins boat ensured that Allied strategy could be executed, not just imagined. It weaponized mobility, and in doing so, it helped open the road to Berlin. When the war ended in 1945, the Higgins boats did not return home in triumph. They did not headline victory parades. They were not preserved in vast numbers. Most were worn out, scrapped, dismantled, or quietly abandoned. And yet, their legacy reshaped military history. By the end of World War II, more than 20,000 LCVPs and related landing craft had been produced. They had carried soldiers across 2 oceans. They had touched the shores of North Africa, Sicily, Italy, Normandy, the Philippines, Iwo Jima, Okinawa, and dozens of smaller islands whose names rarely appear in textbooks. They had turned beaches into gateways. Before World War II, large-scale amphibious invasion was considered one of the most complex and risky operations in warfare. After the war, it became doctrine. The Higgins boat proved that coastline was no longer a natural barrier. It could be crossed deliberately, systematically, at scale. This realization shaped the Cold War. Future amphibious platforms, armored landing vehicles, mechanized landing ships, air cushion craft, all trace conceptual lineage back to the simple wooden and steel hull developed in Louisiana. Modern amphibious assault ships, capable of deploying helicopters and landing vehicles simultaneously, evolved from the logistical logic first demonstrated in Normandy and the Pacific. But the legacy is not only technological, it is industrial. The Higgins Boat symbolized something larger than amphibious warfare. It demonstrated how civilian ingenuity could be adapted to military necessity, how a regional boat builder could transform into a strategic industrial asset, how design simplicity could outperform complexity under pressure. Andrew Higgins himself did not remain a dominant post-war industrial magnate. His company struggled in the years after victory, as military contracts vanished and peacetime markets returned. The urgency that had fueled innovation disappeared, but the design endured. Today, preserved LCVPs sit in museums in the United States and Europe. Visitors see a small craft, compact, almost modest. It does not look like a machine that changed history. Yet history is often shaped by mechanisms that do not appear dramatic. The Higgins Boat was not designed to dominate oceans. It was designed to solve a single problem. How do you move men from sea to land under fire? The answer was not armor. It was not firepower. It was efficiency, repetition, and scale. On the beaches of Normandy, when ramps dropped and soldiers surged forward, the Higgins Boat fulfilled its purpose. It delivered human while onto contested ground. That act, repeated thousands of times across multiple theaters, shifted the balance of global war. In the end, the Higgins Boat represents a quiet truth about modern conflict. Victory does not belong only to the boldest weapon. It belongs to the system that works. And in World War II, few systems worked more reliably than the small landing craft built in New Orleans. The boat that made it possible to turn the tide, one beach at a time.